Hello everyone. Let's solve problem 2 permutations. It's a very good algorithm from backtracking. Let's understand the problem statement. You will be given an array of unique elements. Figure out the possible permutations we could make. Here the array size is 3. So the first element will have 3 possibilities. Second element will have 2 possibilities. And the last element will have 1 possibility. So total we could make 6 permutations, which is equal to n factorial. So when there are n elements, we can make n factorial permutations. So let's see how can we solve this. So we can always start from either element 1 or element 2 or element 3. Let's start with element 1. So if you choose second element as 2, then final element becomes 3. So if you choose next element as 3, then final element becomes 2. So if we start with element 2, if you choose next element as 3, then final element becomes 1. If you choose next element as 1, then final element becomes 3. So if we start with element 3, choosing next element as 1, then final element becomes 2. Choosing next element as 2, then final element becomes 1. So we got all the permutations. If you see here, we have 1 2 3, 1 3 2, 2 3 1, 2 1 3, and 3 1 2, and finally 3 2 1. So these are the permutations we could make. So it's a very good solution with backtracking. Let's see how can we solve it. So we initiate a recursive call with empty list. So we can start with any value. Let's start with index 0, which is element 1. As we choose an element 1, add element 1 to the list. So now list becomes 1. Now we have three possibilities. So obviously we cannot choose element 1 because 1 is already present in list. So let's move on to element 2, so which is not present in list. So we add element 2 to the list, it becomes 1 comma 2. Now from 2 we can still make three possibilities. So 1 we cannot add because it present in list. So 2 we skip the iteration because 2 present in list. Now we move on to 3. So 3 is not present in list, so we add 3, so it becomes 1 2 3. Now if you closely see my current list size, which is equivalent to array length, so we got the permutation, clone the permutation, return to the caller. So while returning to the caller, remove the last element from the list so that you will get the exact list which was made from the caller. With this, from element 2, we seen all possibilities. So return to the caller, by removing the last element, you will get 1. Now it's time to process with element 3. So we add element 3 to the list, it becomes 1 comma 3. Now again we have three possibilities. So we cannot add 1 because it present in list. So we can add 2 because it's not present in list. So now the list becomes 1 3 2. Again the list size is equivalent to array length. So we clone the permutation and add it to the result. Then return to the caller by removing the last element. So you'll get 1 3. Now let's go for 3. We cannot add 3 because 3 present in list. So we are done with all possibilities from 3. So return to the caller, by removing the last element, you will get 1 again. So now you see we figure out the permutations which are starting with element 1. So return to the caller by removing the last element, so you will get empty set again. Now it's time to start with element 2. Add element 2 to the list. Now again we have three possibilities. So we can add 1 because it's not present. So it becomes 2 comma 1. Now from 1 again we have three possibilities. We can skip 1 and 2 because which are not present, which are already present in list. So let's move on to 3. So 3 can be added, it becomes 2 1 3. So we got the permutation. So we clone the permutation, add to the list, return to the caller, by removing the last element, you get 2 1. So you reached all possibilities from element 1. So return to the caller. By removing the last element, you get 2. So we cannot add 2. So because 2 already present in list. Now let's move on to 3. Now add 3, it becomes 2 comma 3. So you have 3 possibilities. So we can skip 2 and 3 because 2 and 3 already present in list. So first let's process with 1. So 1 is not present in list. So we add 1. So which is 2 comma 2 3 1. So now the current list size is equivalent to array length. It means we got the permutation, clone the permutation, add to the result, then return to the caller by removing the last element. So you'll get 2 3. Now we can skip 2 and 3 because which are already present in list. So now we are done with all possibilities from element 3. So return to the caller. Now by removing the last element you will get 2. So we figure out all the permutations starting with 2. So it's time to return to the caller. By removing the last element you will get empty set. Now it's time to start with 3. So you get permutation as list value as 3. We have 3 possibilities. We'll go with 1. Now the list becomes 3 comma 1. Now we'll go with we'll have 3 possibilities, so we can eliminate 1. 1 is already present, so 3 also we can skip because 1 and 3 already present in list. So it's time to go with 2. Now we add 2, so it becomes 3 1 2. So we clone the sub permutation, return to the caller. By removing the last element you will get 3 1. Then it's time to return to its parent. By removing the last element you will get 3. Now we have second element, so which is not present in list, so we add to the list. Now it becomes 3 comma 2. We have 3 possibilities, so we can go with 1. So 1 is not present in list, so it becomes 3 2 1. So we got the permutation because the current length is equivalent to array length. So we clone the permutation, add to the result, return to the caller. By removing the last element you will get 3 comma 2. Now it's time to skip 2 and 3 because both are present in list. So with this we can return to the caller. By removing the last element you will get 3. Now we left with the last one, which is 3, so which is already present in list, so we skip it. We return to the caller. By removing the last element, again you will get empty subset. If you closely see, we figure out all the possible subsets by starting with current element. It's a simple recursive logic. Let's walk through the code for better understanding. So we initiate a recursive call with input numbers and empty list and the result. So our backtrack function includes 3 parameters. The first parameter will be input array, second parameter will be our list, and the third one is going to be the result. So as a first statement, we will see whether the list size is equivalent to array length or not. If it is equal, it means we figure out a permutation. So clone the permutation, add it to the result, then return to the caller. Otherwise, we initiate from index 0, we move till array length. So for each iteration, we compare whether the current element present in list or not. If it is present, we skip the iteration. Otherwise, we add the current element to the list. Then we make a backtrack call with the updated list. So once we are done with recursion, while returning to the caller, we remove the last element from the list. That's it. It's a simple logic, but it needs very good visualization. So if you don't get clarity on this code, please go back and watch the video again. You will get full clarity. So let's understand the time complexity. As we know that, so we were able to make n factorial permutations, and whenever we made a permutation, we clone the n elements into the list. So the time complexity will be n into n factorial, where n is number of elements we copy, n factorial is number of permutations we are making. The space complexity here is if you don't consider result, so at max only n stack frames gets activated at any point in time, so the space complexity will be linear. If you consider the result, then the complexity obviously n factorial. That's it. So let's go and submit the code. So if you closely see, we have a empty result and we are also passing empty list to the backtrack method. Let's see. So whenever our list size is reaching the array length, we clone the permutation, then add to the result, then return to the column. If not, then we start from first element, we move till the end, and we see current element present in list or not. If it is present, we just skip the iteration. Otherwise, we add the current element to the list, then we do the backtrack method. We call the backtrack method with the updated list. Once we are done with recursion, we just remove the last element from the list. That's it. So let me submit the code. That's it. Hope you like the explanation. Please do subscribe and share. Thanks for watching. So thanks for your time.